Okay, so we'll be doing course schedule 2. There are total number of courses. Let's say it's n. Uh, let's say we have n number of courses and we have labeled them from 0 to n minus 1. Okay, then you're given an array prerequisites where prerequisites I has two values, is a vector of vectors, and this is index 0, this is index 1, and when we say A and B are a part of prerequisite I, that means you have to take course B first and then only you can take course A. Okay, so we can say कि there is a directed edge from B to A. So let's say we have the pair 0, 1. So we would say कि the edge is something like 1 to 0. You have to first take course 1 and then only you can take course 0. Return the ordering of courses you should take to finish all courses. Now since we can see there is a kind of hierarchy that you have to take 1 and then only you can take 0, so we can think that maybe topological sort can be used for this question. So let's try and code it up now. So first of all, I'll make n. I'll declare int variable n equals to num courses. Okay. Then I'll make a adjacency list vector of int jlist n comma vector in. Then I will go through the prerequisites array vector 0 and then size I plus plus e to jlist 3 I 1 dot question 0. We're going from 1 to 0 because as you can see it's ulta यहाँ पे, so that's why B to A. And also we can say this is a directed graph, so we'll only have one line of code over here. Now since we have the adjacency list, after that what we can do is I'll explain what happens in a topological sort. Okay, so in a topological sort it is very similar to DFS, but let's say we have an array. Let's take this example. So we have a graph 0, 1, 2, 3. Okay, we have edges 0 to 1 and 0 to 2, 3 to 1, sorry 1 to 3 and 2 to 3. Okay, now what we can do is we'll start the topological sort from, let's say, this particular node. Okay, so we'll do visited of u equals to true. After that we'll do topological sort for all neighbors of u, and then we'll push u to a stack. Okay, so what we're essentially doing will push you to a stack, and then at the end we'll just empty the stack, which will give us the topological sorting. Okay, so let's do a dry run on this one. Initially we'll have a visited array. Let's say it is 0 1 2 3, and initially it is false 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 false. Okay, now we did topological sort on 0, so we'll do this, mark it as true, then we'll do it on the neighbors of 0. So neighbors of 0 are 1 and 2. Okay, so for 1 we'll again mark it as true. We'll do the topological sort for 1, which is 3. Okay, so 3 we'll mark it as true. We'll do topological sort for neighbors of 3. There are no neighbors, so we'll now add 3 to the stack. Okay, then we'll come to 1 and we'll see if there are any more neighbors. There are no more neighbors, so we'll add 1 to the stack. Then we'll come to 0, we'll see if there are any more neighbors. Yes, there are. 2 is there, so we'll do 2 ka true, and then we'll see neighbors of 2, which is 3, but 3 is already marked as true. Okay, so in that case we'll return, and we'll again see 0, and we'll see if there are any more neighbors left. There are no neighbors left, so we'll sorry, for 2 we are supposed to add it. Then for 0, since there are no more neighbors left, so we'll add it also to the stack, and this is the stack. Now all we need to do is we have to pop the stack. So we'll do it 0 2 1 3. Now this is a topological sorting. Okay, and we can see that is the answer we get here. So this is how it works. So what are the things we need as a part of topological sort? We need a stack, we need the visited array, and that is it. Okay, so let's code it up. I'll have a visited array, which will be a vector bool, and comma, let's initialize it to false. Then I'll have a stack I'll call it as a topo stack. Okay, then I'll call the topo sort function. I'll pass the array, the starting node. Let's say it's 0 in this case, and we know that there will always be a 0 course number because the courses start from 1. So 0, comma, the visited array, then the topo stack, then the graph as a adjacency list. Now I'll write the topo sort function. It will be a void function, sort. We have int u, comma, vector int and visited, and a stack, and we're passing all of this by reference. Stack int and let's call it stack over here also, and we'll have a vector int list should also be by reference. then we can start it. Okay, so first we check if that particular node is already visited or not. So let's say it's visited. So if visited of view is true, then we just return, because we don't want to go into an infinite loop. Okay, else we do visited of view equals to true. After that, what we'll do is we'll look at all the neighbors. List of view. We'll do topo on V visited topo stack integer list. Then we'll push this particular vector, this particular node to the stack. Okay, so let's erase some of this from here. Okay. Yeah. So we did topological sorting, then we'll have a after that we'll have a function which checks also, like over here topological sort, this function only works in case of a directed acyclic graph. So we know that this graph is directed. Now we just need to check if it's acyclic or not. In case it is not acyclic, then we cannot have an ordering, because let's say we have three nodes like this. Let's say we have three nodes, 1, 2 and 3. Okay, and we have a cycle. So we can never say ki, what the order of courses that needs to be done, because 3, 2, 1, 1, 2, 3, 2, 1, 3. In every case, like wherever we are starting, it has an edge coming towards it. Means something needs to be done before it, and we'll never get ordering which is going to work because we have a cycle. So over here I'll make another function called boolean called check cycle. Okay, and I'll add the stack. And the adjacency list by reference. All of this needs to be sent by reference. Vector of int called EGGLIC. And now what I can do is, in a topological sorting, if it happens so that there is a parent which is coming after the child, that means we have found a cycle. Okay, so what I'll do is I'll have a map in mind called position. Okay, now I'll have a index equals to 0 actually. Now what I'll do is for equal to 0 less than list dot size and plus plus child of every node, we get it from the adj list of I. What I'm going to do is also I'll have a vector. I'll also pass the answer vector over here, in which I'm going to store the topological sorting. So my not topo stack dot empty, I'm gonna add that particular node to the answer vector dot and to index plus and I'll drop it. Okay, so now I'll have all the values. Now if over here loop position of index, yeah, I think this is correct. Now I'll say if position of parent greater than position of child, means the parent is coming after the child, then we return true, means we found a cycle. Otherwise we just return false. Okay, so let's clear the screen. So if we find a cycle, also over here we need to clear the answer vector in the answer. Okay, if check cycle topo stack adj list answer is true, means we found a cycle, right? Then we return empty vector, else we return the answer vector. Now we'll run this code. Index, I need to declare it as an int. Line 35. This is pool. Sorry. Oh, this is end only. Visited should be pool. Pool. Okay. Let's submit this. Why are we getting a wrong answer? Input two nodes 0 and 1, and we don't have any edges. Output I should get both 1 and 0, right? Only okay, because I'm calling the topo sort function just for 0. Okay, so I'll do this. I less than n, I plus plus, if not visited I. In that case, I'll call topo function, and this should be okay. Let's see. Okay, so it works. So the time complexity for this function should be okay. We have d topo sort function is running, and topo sort function is almost the same as dfs, so it is O of b plus e, and the space complexity should be O of v, because we have a stack also in this case. So that should be the answer.